Sorry, I was pressing the buttons wrong. Okay, looks scary, this one. Parabola, upside down quadratic, given its equation. Circle, we're not given its equation, but we are, because they tell us it's got centre, naught and radius 2, so we can get that. Circle and the parabola meet. So this is where, if we did simultaneous equations on the parabola equation and the circle equation, we'd get two answers. One of the answers would be the coordinates of P and the other answer would be the coordinates of Q, because simultaneous equations tells you where these two graphs cross each other, and the parabola and the circle cross at P and Q. I'm just going to write down the circle equation. So it's got, radius 2, centre, naught, naught. So the equation is x squared plus y squared equals 4. And what we're interested in is where this one crosses, intersects that one. Okay, let's look at the question. Oh, hang on, where's the question gone? There. Right. Verify that okay, so they're telling us the coordinates of Q, but we have to check they're right. So they're saying, I've done simultaneous equations on these two equations, solve, solve, solve. I've got the coordinates of Q as a solution, and they come out to be that when x is 1, y is √3, and that point is on the parabola, and it's also on the circle, so it's where the circle and the parabola intersect. Now what you've done is you've said, let's look at the parabola. What happens if x is 1? Now this is perfect, because you're not subbing in, but we don't want to sub in both, because that means we're saying that we're sure that when x is 1, y is √3, and the point is we're checking what is the y coordinate on the parabola when x is 1. So you sub in x is 1, nice and clear. You said what you're finding, y equals, perfect. Found an answer. I don't know if it's right or not because I haven't got the mark scheme, but find that. And there you've said point Q, oh wait, point Q can't lie on a point. Point Q is 1√3. So you've said here, point Q lies on Q. That's not what you found. What you found is that point Q lies on the parabola. Lovely sentence to put at the end, but we're only halfway, sadly, because that's perfect, but then what we want is the exact same thing here for the circle. So let x equal 1. What does y equals? La 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 la. Well, you wouldn't say y equals at the beginning because it's a circle, but this, y equals √3, and then the sentence, therefore point Q lies on the circle. Then maybe another sentence just to tie it all up. The point Q lies on the parabola and the circle. Oh, yeah, because how do we know that 1√3 isn't the coordinates of point P? Yeah, because P, can't remember what it looked like now, circle, parabola. So P and Q both lie on both. So if I check that it's on the parabola and then check it's on the circle, that still doesn't mean that I found Q. I might have found P. How do I know that I found Q? The x coordinate is 1, which is positive, so it must be Q, because the x coordinate of P is negative, because it's to the left of the y-axis, something like that. So lots of missing stuff there, but almost perfect what you did first of all. Okay, find the exact area of the shaded region. Now the thing that strikes me first of all here is that there is no picture. I can't do these questions without a picture. To try to get your brain to put all the pieces together in the right way without a picture, you're asking a lot of your brain, and it's not necessary because we could just draw a picture. So let me just draw for a sec what we want. Oops. We want this area. Sorry, it's a rubbish picture, but nah. Let's get rid of everything that I'm not interested in. All this bit down here I'm not interested in. To be honest, I'm not even interested in this stuff. I've got the parabola coming down like that. The circle is bigger than the parabola. That's the x-axis, that's the y-axis. Doesn't have to be a work of art, as you can see. That's what I want. That's what they're asking me to find. Okay, how am I going to do that? I am going to integrate the parabola from there to there. Now, how do I know that the x-coordinate of P is -1? Because it's symmetric. The circle is symmetric because its centre is 0, 0. The parabola is symmetric because if you look at its equation, you'll see that it's just been flipped upside down, stretched and moved up, hasn't been moved left or right at all. So that's symmetric as well, and I know that the x-coordinate of Q is 1, so the x-coordinate of P is -1. So that's what I want to do first. That's what you've done. Look here. Integral -1, 1, missing dx. Also, still using integral sign, not putting an equals sign. Oh no, look. Here it is, sorry. I've covered it up. Here's the correct bit. Here's the integral from -1 to 1 of the parabola missing dx. Then we integrate. Oh no. No, your poor brain having to deal with all these things that are written which we're supposed to ignore. So here's the integral -1, 1 missing dx. Then we've integrated here. That's where we integrate from there to there. Okay, looks like you've integrated correctly, but as I say, I'll check all the details later. So now we have big square brackets, and we put -1 at the bottom and 1 at the top, and then you're letting x equal 1, so this integral sign shouldn't be here, but there's x equaling 1. And now you haven't written it, but let x equal -1. Again, let's get rid of that integral sign. So there it is. Oh, you did write that there after it happened. And then you've got that number. Now, I don't know. Oh, look. Yeah. See, I don't know. When you wrote equals a√3/3, I don't know whether you think this is a√3/3 because I've just noticed this little minus sign. I assume it's a minus sign because you would put top limit minus bottom limit, right? So I think that's a minus sign. So I don't know, is this equal to this, or is this equal to this minus this? Because I can only give you the method mark if I can see that you have done sub in the top limit, then minus, then sub in the bottom limit, and you've done that. So now, as the examiner, I've got to get a calculator out and see whether when you wrote that you might be meaning this minus this, or whether you were just meaning this, because it's not clear from the way it's written. So let's assume that you think this is that minus that, which is this area here. Okay, now you know that we want to take something off that because you can see that we don't want that whole area. Again, no pictures to guide you here. I would be pictures all the way at this point. This is a really difficult problem. So, how are we going to extract this area under the circle? Because you can't integrate a circle. Can't make it say y equals, so you can't integrate the circle from -1 to 1. So you've got exactly the right idea. You're thinking about sectors and you're thinking about triangles. It's perfect. Perfect. I can see exactly what you're doing. It's a little bit confused. The layout makes it harder for me as an examiner to read it and work out what's going on. But I think this is what you're doing. I think that you are saying, if I wanted to find this area under the circle, then I can find the area of the whole sector by doing a half r² theta if I knew the radius. Oh, which you do, because you know it's on the circle and the radius is 2, so you're completely right. Look, r is 2, but you'd have to know the angle, which is where you've then thought, but I don't know the angle. Well, we can find the angle. Of course we can. Can we? Yes, I think we can find the angle. We are going from the point 0, 0 up to the point 1 root 3. Let's make it like this with a 90 degrees there. That's the angle that we want. That distance across the top is 1, because we're going across 1 up root 3. This is root 3. So tan of the angle is the opposite over the hypotenuse, and then you can find the theta, and then if you double that, you'll have that angle, and then you can sub that in there. That was a little bit tricky, I admit. That was a bit tricky, but it was doable. We could have found that, and then we would know the area of the sector. But that's still no good, because the thing that we want to take off our green bit, the thing that we want to take off there is, let's change colour, is this. Dun, 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 and that. Now the rectangle bit, I could find the area of that, couldn't I? Bear in mind I now know the area of the sector. I can find the area of this because I know that it's 2 across. And I know that it's root 3 up. Because the coordinates of P and Q are 1 root 3 and minus 1 root 3. So I can easily get the area of that rectangle. I can take that rectangle away from the green integral, and then I'm getting there, but I also need to take away this annoying little bit at the top, which is why we need the area of the sector. But then, surely there's an easier way than this. Then we go, right, well, in that case, now I need to find this area. Oh, I know how we could do it differently. Anyway, this bit we can find, because this is a half r squared theta minus a half r squared sine theta. That little top of the ice cream bit is the whole sector minus the triangle. So we could find that. That would be okay, because we know theta and we know r. So we could do that, and then we'd have the whole sector. Then we'd have the little bit at the top, the little ice creamy bit. And then we could add the little ice creamy bit onto the area of this rectangle. Then we could take both of those away from this integral, and then we'd have the answer. Wow. The other thing I just thought is, actually, now that we've got the area of the sector, we could find the area of that triangle, because we know how far across and how far up, half base times height. Let's see if that's what you were doing. And then the area of this triangle, half base times height, and then add them up, and then add that to the sector and take them away from the green integral, and then we'd have the answer. Area of triangle, half base times height. Your base is 1, your height is 3, root 3. That's the area of one triangle, root 3 over 2. Then you've doubled it. You have done that. But see how hard it was for me as the examiner to find out what you were doing so that I can then give you method marks. The best bit of this whole answer is the fact that you wrote area of triangle, area of sector. Like, there's some confusion equals even here. Like, you've gone that. Then I had to go backwards and read another equals. So, see, that does equal that, but doesn't equal, no. I think you knew exactly what you were doing here. I think you did the integral to get the green area. Then you were looking at this area, and then you were thinking, I'm going to find the area of the sector and then add on these two triangles. And then you did the triangles here. And then you tried to do the sector, which was here, but you didn't have the confidence to go on and just unlock the entire thing by finding that value of theta, which I understand that's difficult. I don't know where that, oh, that's that times that. So root 3 is these two added up. But see how, oh, there's an arrow. I think I go here, 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 but without the equal sign. There. Yeah. And then, right, say that this is 8 marks. This is nearly an entire grade, right? That you 100% know how to do. 100%. If you had made up a theta at this stage, so you just wrote theta is pi by 3, whatever, then you'd written this minus that, I could give you another mark. I might even be able to give you another 2 or 3 marks. I don't know, depends on the mark scheme. But that's the lack of confidence coming in. I think it's the lack of confidence twice. Once, because you thought, I've probably gone wrong already. I'm not even going to try to find theta because I think I've already gone wrong. And next, that you've abandoned the possibility of picking up more marks even with what you've done because you're just walking away rather than tying up what you've done in order to take it to its conclusion so that you can show the examiner that you 100% understood what was going on here. I'm sorry this one was a really long one, but I think it flags up a lot of issues, and I think you need to hear a big well done for what you did here, because this is a very hard question and you almost nailed it. Okay, let's look at the next question.